One variable inequalities. In this video, you'll learn how to graph the solution to an inequality in one variable. You'll also learn how to solve one variable inequalities and interpret the solutions in terms of the situation. Let's start by looking at solutions. An equation has one specific solution that will make the equation true, but an inequality has a range of possible solutions, and this is often shown on a number line. We'll use open dots for the symbols less than and greater than, and we'll use closed dots for the symbols of less than or equal to and greater than or equal to. Let's start by practicing graphing inequalities. So we'll start with x is greater than 4. Since our symbol is greater than, we'll put an open dot on 4. This just shows us that it's not allowed to equal 4. And then to show that we want all values greater than 4, we'll draw a line showing all values greater than 4 by going to the right. Now let's look at x is greater than or equal to 2. Since our symbol is greater than or equal to, we'll put a closed dot on 2. And since we want all values greater than 2, we'll draw our line to the right again since all of these values are greater than 2. Now let's look at x is less than or equal to 7. Since it's less than or equal to, we'll put a closed dot on 7. And since we want values less than 7, we'll draw a line to the left since all of these numbers are smaller. Now let's look at solving inequalities. Solving inequalities are similar to solving equations. The only difference is that multiplying or dividing by a negative value will flip the inequality symbol. This is because if we have an inequality like 5 is greater than 2, which is a true statement, and we multiply each side by -1, we'll get that -5 is greater than -2. But this isn't true, since -5 is smaller than -2. So we'll have to flip our inequality symbol anytime we multiply or divide by a negative number. Let's practice by solving some inequalities. Our first example is 2x plus 5 is less than 11. We'll start by subtracting 5 on each side. This gives us 2x is less than 6. Now we'll divide both sides by 2, which gives us x is less than 3. Let's try another one. This time we have 3x over -4 is greater than or equal to 6. We'll start by multiplying by that denominator since that will help us get rid of the fraction. So we'll multiply both sides by -4. This will give us 3x and then -24. But since we multiplied by a negative, we need to make sure that we flip our inequality symbol. So now we can keep solving. We'll divide both sides by 3 to get x by itself. And this gives us x is less than or equal to -8. Now let's try to solve x plus 6 is less than or equal to 3x plus 1 divided by 2. We'll start by multiplying by our denominator again since that will help us get rid of the fraction. This gives us 2x plus 12 on the left side and 3x plus 1 on the right side since it just got rid of the denominator. Now we'll subtract 2x from each side so that we can get the x variables on one side. This gives us 12 is less than or equal to x plus 1. So now our last step is to subtract 1 from both sides so that x will be by itself. So we get 11 is less than or equal to x. So any values greater than or equal to 11 will satisfy this inequality. Now we're going to decide what values will make this inequality true. So we have the inequality and then we have 4 options that can satisfy this inequality. So let's solve the inequality and then we'll see which of our values fit in our range. We'll start by multiplying both sides by 2 to get rid of that fraction. This gives us 7x plus 6 on the left side and 6x plus 4 on the right side. We have to make sure to multiply every term by that 2. Now we're going to subtract 6x from both sides so that our x variables can just be on one side. This gives us x plus 6 is less than or equal to 4. So our last step to get x isolated is to subtract 6 from both sides. This gives us x is less than or equal to -2. So any values equal to -2 or less than -2 will be solutions. So in our examples, our only options are -3 and -2, and these would satisfy our inequality. Let's look at solving another inequality. We'll start by multiplying by our denominator, and this gives us 4x minus 6 is greater than 2x minus 5. Now we'll try to get our variables on just one side of the inequality. So we'll subtract that 2x from both sides. This gives us 2x minus 6 is greater than negative 5. Now to get x by itself, we're going to add 6 to both sides. This gives us 2x is greater than 1. And our last step is to divide both sides by that coefficient of 2. This gives us a final answer of x is greater than 1/2. Let's try one more, and when we're done solving this, we'll graph the inequality. We'll start by distributing that 3 to the parentheses. This gives us 6x plus 12. Now we'll try to get the variables on one side. It doesn't matter which variable we move, but moving the smaller one helps us avoid negatives, so we'll subtract that 6x from both sides. This gives us 5 plus 2x is less than 12. Now we'll subtract that 5 from both sides to get the x isolated. This gives us 2x is less than 7. Our last step is to divide by that coefficient of 2, which gives us a final answer of x is less than 7/2 or 3.5. So now let's graph our solution, which we had was x is less than 3.5. The symbol less than tells us we'll put an open dot on 3.5. And since we want all values less than that, our line will go to the left. Now let's recap what we've learned. While equations have one solution that make it true, inequalities have a range of values that make it true. We can solve inequalities just like equations, except when multiplying or dividing by a negative, where we need to switch the sign.